When you look up at the night sky, do you feel that all the stars and planets are revolving around you? For thousands of years, we believed that we were at the very center of the universe because of this innate feeling. Because it was simple, it made sense. But this was a great misconception. Our senses deceive us. In this third episode of the Astronomy for Beginners series, we will unravel step by step how we overcame that misconception, the illusion of the celestial sphere, and how the Earth's rotation on its own axis shows us the sky. Human senses may not always perceive reality as it truly is. Observations such as the stationary appearance of the Earth's surface, the sun rising in the east and setting in the west, and the moon and stars following a similar path, led to the long-held belief that the Earth was the fixed center of the universe. This Earth-centered model, known as geocentric, was widely accepted throughout history due to its simplicity and intuitive appearance. This belief, which dates back to the European Renaissance, was accepted as one of the cornerstones of scientific thought for thousands of years. Furthermore, it went beyond being merely an astronomical model and provided a basis for philosophical and religious systems. If everything revolved around humans, this reinforced the idea that the human race held a central and privileged position in the universe. One of the most significant turning points in our intellectual history is the rejection of geocentric thinking. With this shift, we left behind the idea that we were at the center of the universe. Now, let us take a closer look at how we reassessed our place in the cosmic order and what reality lies behind the deceptive motion of the celestial sphere above us. Imagine for a moment that you are camping in a place far from city lights on a clear night. When you look up at the sky, you see almost the same view that people have seen throughout history. When you lift your head, you feel as if the sky is a vast, empty dome. You find yourself at the very center of this dome, seeing all the stars as being equidistant and settled on the surface of the dome. We call the point directly overhead the zenith, and the line where the dome meets the Earth is called the horizon. When you lie down in a field at night and watch the sky, you notice that the stars and moon rise in the east, travel across the sky as the night progresses, and set in the west. Observing this cycle repeatedly, you inevitably come to think that the sky actually looks like a giant sphere rotating around you. The ancient Greeks perceived the sky as a real celestial sphere. Some even thought it consisted of a transparent crystal sphere with stars placed on it like small jewels. Although we now know this to be a misconception, we still use this imaginary dome or sphere concept to determine the positions of objects in the sky, just as in a planetarium, where stars are projected onto a white dome to recreate this illusion. Today, rather than a sphere moving across the sky, it is accepted that the cause of the day and night cycle is the rotation of the planet we live on around its own axis. The Earth completes a full rotation every 24 hours around an imaginary axis that is assumed to connect the North and South poles. This rotation is also the fundamental reason for the regular rising and setting of the sun, moon, and stars. Furthermore, it has been scientifically determined that these celestial bodies are not positioned on a dome, but at different distances in space. Although the celestial sphere appears to rotate when observed, the celestial bodies on it maintain their positions relative to each other. For example, the shape of constellations such as the Big Dipper remains unchanged during the sphere's rotation. Even nearby planets that move throughout the night are observed to largely maintain their positions relative to the stars. The exception to this rule is celestial objects known as meteors or shooting stars, which only briefly enter our field of vision. The fundamental difference between meteors and other celestial bodies is that they are not actually stars. They are small pieces of cosmic dust that burn up and disappear when they enter Earth's atmosphere. The fact that the celestial sphere moves as a whole contributes to the development of observation technologies that enable the systematic tracking of the positions of objects in the sky. Astronomers use a system based on the extension of the Earth's axis to facilitate orientation in the sky. The imaginary axis connecting the Earth's north and south poles, when extended in this direction, intersects the celestial sphere at points called the North Celestial Pole and the South Celestial Pole. As the Earth rotates on its axis, the movement of celestial bodies in the sky is observed as if rotating in the opposite direction around these poles. Similarly, the imaginary projection of the Earth's equator onto the sky is called the celestial equator. Just as the Earth's equator lies at the midpoint between the planet's two poles, the celestial equator lies exactly between the celestial poles and divides the celestial sphere into two equal parts. Understanding this system provides a fundamental reference point for comprehending how we see the sky in different regions of our planet. The observed movement of the celestial sphere, however, varies depending on the latitude of the observer, whether they are north or south of the equator. Let us examine how being in different regions of the world affects the appearance of the sky. Since the Earth's axis is oriented towards the celestial poles, these 2 points remain fixed in the sky and do not move. If you are located at the North Pole, the North Celestial Pole is directly overhead at the zenith. The celestial equator lies exactly on the horizon. In such a position, the stars move in a circular pattern around the North Celestial Pole throughout the night, and no star dips below the horizon. Therefore, only the northern half of the sky is observable. When you are at the equator, the celestial equator passes directly overhead at zenith. The celestial poles are located at the northern and southern points of the horizon. In this position, all stars rise in the east and set in the west. They ascend upwards and then descend downwards. Stars are visible on the horizon for half of the 24-hour period. How does an observer at mid-latitudes like Germany and the USA view the celestial sphere? We are neither at the pole nor at the equator. We are positioned exactly between the two. In these regions, the North Celestial Pole is neither directly overhead nor on the horizon. It is between the two. The North Star rises at an angle equal to your latitude on the northern horizon. For example, if you are in San Francisco at 38 degrees north latitude, the North Celestial Pole will appear 38 degrees above the horizon. In this case, the entire sky rotates around the North Celestial Pole. Stars near your latitude never set. This region is called the Northern Circumpolar region. Similarly, stars near the South Celestial Pole, which is as far away as your latitude, never rise. That region is called the Southern Circumpolar region. In modern world history, Polaris, the North Star, located quite close to the North Celestial Pole, is one of the least moving stars in the sky. While the sky in the northern hemisphere rotates daily, Polaris's relative immobility is striking. Because of this characteristic, some Native American tribes have attributed special meaning to Polaris in their mythology. For example, it has been described as the nail of the sky. The next time you watch the stars rise and fall in the sky, remember that you are not witnessing the movement of a giant dome, but rather the immense motion of the planet you are on as it rotates on its own axis. In light of the information obtained, we can evaluate our view of the sky on a more scientific basis. Although the celestial sphere model is not entirely accurate, it remains a functional tool for determining the positions of celestial bodies and for navigation. With the accumulation of knowledge from ancient times to the present day, we have come to understand that we are not the center of the universe. However, we still maintain our special place on our own planet. If this video has opened a new window for you to view the sky, please remember to like the video and share your thoughts on these topics in the comments. To learn more on this journey of scientific discovery, you can support us by subscribing to our channel. See you in the next video.